All right, hello again, and welcome to another one of Mr. Martin's math videos. Here, this is a math BC curriculum Math 9 video in Chapter 5, Section 3, Graphing Linear Relations. So here we've been talking about how to come up with an equation using rate of change and the initial values, right? The equation in the form of y equals mx plus b. Now we're going to figure out how to put these equations onto a graph. Okay, so for this chapter, for this homework, you're going to need some graph paper to make some proper graphs, okay, and a ruler to make straight lines. All right, so let's get started. So by the end of this lesson, you should be able to graph linear equations and also solve problems by graphing a linear relation and analyzing the graph. Okay, so it's not enough for us just to be able to draw a graph. We also have to know what we're drawing and be able to interpret what it's all about. So last time we looked at what graphs were and how they were used to communicate patterns and behaviors in data. Okay, we learned how to interpolate and extrapolate. Today we're going to be using tables and equations to draw our graphs. All right. So for the first kind of concept here, we're going to have this example question. The world's largest cruise ship, Freedom of the Sea, I'm right here, uses fuel at a rate of 12,800 kilograms per hour. By comparison, your car takes about 7.7 kilograms per hour of gasoline. So it is not what we would call in the industry fuel efficient. The fuel consumption, F, in kilograms, could be modeled by using the equation F is equal to 12,800 T. Okay, F being the responding or dependent variable. Okay, because the amount of time that passes is the independent variable, and then F then is the total amount of fuel consumption. All right, so as time passes of the boat traveling, the fuel consumption is going to increase. All right, so we want to create a graph to represent the linear relation for the first 7 hours. All right, so how do you turn an equation into a graph? We're going to use a table to do that. Okay, so in the left side here, remember the left side of the our table is our independent variable, and on the right side is our dependent variable. Okay, I'm gonna make my cursors a little bit bigger. All right, so independent variables we said was time, and that's measured in hours, and our dependent variable is fuel consumption measured in kilograms. All right, so let's take a look. After 0 hours, we'll start with 0, and we're going to get to 7. Okay, after 0 hours, how much fuel has been burnt? Okay, well here you can always use your equation. F is equal to 12,800 T, and then you just plug in the values of T with the values that you've decided. So hour 1, hour 2, hour 3, hour 4, hour 5, hour 6, hour 7. Okay, so F is equal to 12,800 times 0, okay, would equal 0 kilograms. Okay, that's not surprising. F is equal to 12,800. If we were to solve for 1 hour, that would equal to 12,800 kilograms. Okay, and same thing for all of them, right? You're just plugging in your x values, or in this case your t values, your independent values, into the equation, and then getting your f values. 25,600. Just double check. Yeah. And so on and so forth. All right, so nope, that's not 12,000. It would be 25,600. 100, and then times 3, right? 3 times 12,800 would give me 38,400. 4 times 12,800 is 51,200. 5 times 12,800 would give me 64,000. 6 times 12,800 would give me 76,800. And 7 times 12,800 would give me 89,600. Okay, so now we have our values, our table of values. So essentially by doing our table of values, it gives us points on the graph to be able to plug in. Okay, the table of values, the coordinates of their table of values actually give you the coordinates that you're going to plug in. So the first coordinate is going to be 0, 0, right? Remember your coordinates when you're plugging them in, it's always x and y, which works out well. This is why I always say that you have in your table, you need independent on the left and dependent on the right, because that means your numbers, when you plug them into, coordinate points on a Cartesian plane, will be independent on the left and dependent on the right. Okay, so here my points on the graph are just going to be these points here, right? 2 and 25, 6, 0, 0. 3 and 38, 4, 0, 0. 4 and 51, 2, 2, 0. Oops. 5 and 64,000. 6 and 76,800, and 7 and 89,600. Okay, so here we have all of these points. Now I'm going to take these points and put them on my graph, and then I'll be able to connect those points with a line. Okay, well, we can discuss if it's appropriate for us to connect these points with a line. Okay, so what you need on a graph, okay, is first of all you need a title, some kind of title. So this is fuel over time, right? Doesn't have to be a creative title, just descriptive is probably best. Your x variables, independent variables, are always on the x-axis, right? This is the x-axis, and it holds the independent variables. Okay, so here it's time, right? We said that time is our independent variable in hours, and each of these is going to be 1, right? So this is 1, 2, 3, 4, 5, 6, 7. Okay, 8 if we want, 9, 10, 11. All right, good. Now this axis here, okay, this is our y-axis, and it holds the dependent variables. Okay, we said dependent variable is the fuel consumption. So here, can I go up by 1, 2, 3, 4, 5 like I did for time? No, right? I'm not going to get to 89,000 if I go up by 1 here. And so what I'm going to go up by, I'm going to go up by 30, 45, 60. Maybe I'm going to go up by 15,000s. Each one of these lines is going to represent 15,000. Okay. The key for these here. So we said this is fuel consumption in kilograms. All right. And each of these is going to be 15,000. So this is going to be here. I'm going to write it the abbreviated way. So this is 15K. This is 30K. K just is the 1,000. Okay. This is 45K. This is 60K. This is 75K. This is 90K. This is 105K. This is 120K. This is 135K. This is 150K. All right. Okay, so now I'm going to plot my points. Okay, just make sure when you're picking, how much you go by, just make sure each space is by the same amount. Okay, each of these spaces should represent 15,000. Okay, in order for your graph to be correct. Okay. Now let's plot these points. First point, 0, 0. Second point, 1 and 12,000, so that's about there. Second point, 2 and 125, which would be about like there. 3 and 38 should be like there. 4 and 50, which would be like here. 5 and 65, 4, which would be like here. 6 and 76, which would be just over 75. 7 and 9 would be like here. Okay, so you're just, each of these points here, I'm plugging, just to be clear, these points are what's going into my graph here. Okay, and so the numbers on the left-hand side are my numbers on the bottom, and then the numbers on the right-hand side are my numbers along the left side. So I find my x value, I go to that x value. So for example, let's take this one. Let's take 6. So for number 6, for example, I go to number 6, and then I go up number 6 until I hit about 76,000, so close to 75,000. And then where the 76,000 and or 77,000 and the 6 kind of intersect, that's where I draw my dot. Okay, just as a review for how to graph points on a graph. Okay, now I can draw a line, all right, to demonstrate this. Now this line software is not very good on this app, unfortunately. So, but we're going to try it. Oh, a highlighted line. Okay, that's fine. Okay, so this would be our line, right? I'm going to draw an actual red line here. Oops. Shape, line. Nope. Shape, line. All right. Inside of the green. All right, something like that. Okay, here I can even probably erase the green. There we go. So that's kind of my line here that I have. And now a couple questions. I just connected these dots. A couple questions though that we should be asking ourselves. First of all, is it reasonable for me to connect these lines with a dot? Right? So the question I'm really getting to is, are there, does the fuel only get consumed all at once when the clock strikes the next hour? Or is fuel being consumed along the way every single second between 1 hour and the second hour? Okay, is it a continuous relationship, which would represent a line, or a discrete relationship, which would just mean the dots, okay, along the line? So in this situation, we can assume that this should, oh man, I'm just going to leave those dots there. It'd be too hard to erase. This is a continuous relationship because gas is not just being burnt on the hour, it's being burnt every second between the hours, right? Because the engines are running nonstop. So gas is being consumed nonstop, all right? So this is our graph. And we have our title, we have our axes labeled, and we have our points plotted. And in this case, it was appropriate for us to connect the dots. So now they're asking us approximately how much fuel is used in 11 hours. Okay, so here, 11 hours. Are we being asked to interpolate or extrapolate? So here, we're being asked to extrapolate, right? So luckily, I drew my line beyond the dots, okay, the 11th hour. All right, so at 11, okay, if I go all the way to the line for 11, I'm going to say that that's about here. I go over, and I don't know, that looks like maybe 140K, something like that. That's my estimation. 140K or 140,000 kilograms in 11 hours, okay, of that cruise ship trucking along. Now, is it a fair assumption for me to extend this line straight? If the gas consumption for the first 7 hours is like that, will it be pretty much the same from hour 7 to hour 11? Yeah, it's a fairly safe assumption. Like even if he has to stop for gas, once he starts up again, the fuel consumption is going to be pretty constant. So it's a fair assumption for me to extend that line. Now I'm going to work backwards here. We're going to, not work backwards, but they're going to give me, so we approximate using the graph. However, we can also use the equation to find the exact answer, right? So by using the equation, it would be F is equal to 12,800 T, which would equal 12,800 times 11, which would equal, oh, wow, we did pretty well. 140,800. We were only 800 kilograms off, which seems like a large amount, but relatively quite small, right? So this was a very good approximation based on the extrapolation of the line on the graph, okay? Again here, how long can the ship travel if it has approximately 122,000 kilograms of fuel? So this time I'm going to go from 122 kilograms, which is just above the 120, and then come down. It's between 9 and 10 hours. I'm going to say about 9.4. It's a little bit under 9.5. Actually, that's pretty 9.5. I gotta say 9.5 hours. Okay, so my approximation. And here we're still extrapolating, right? It's still beyond the last point. So we're still extrapolating. And I'm going to say about 9.5 hours. Okay, now again, we can check with our equation is equal to 12,800 times time. Here, they give me my F value, and they want me to solve for T. So I put 122,000 kilograms is equal to 12,800 T. In order to solve for T, I need to divide both sides by 12,800. And I get an answer of, divided by 12,800, and I get an answer of 9.5. Time is equal to 9.5. I can maybe add one more digit here of precision, 9.53 hours. So again, my approximations are pretty good, I'd say, based on the extrapolation on the graph, okay, compared to the exact answers given from the formula. So, using a graph to approximate values is actually very helpful because it can be a lot faster, and sometimes we don't need the exact values. We just need approximates to kind of have an idea of how long it'll last us, okay? Let's try another one. Here, there's no word problem here. They just give us an equation, okay? But again, we're going to go about the same way. I have my x variables here, y, right? Independent on the left, dependent on the right. That's going to give me points here for this. And then you just plug in, let's plug in 0, 1, 2, 3, 4, 5, 6, 7. So y is equal to 2x minus 5 is my equation. So let's start plugging in some of these x values. This is 2 to the 0 minus 5, which is equal to negative 5. So, negative 5, which makes sense, right? Because my initial value is when x is equal to 0, which is negative 5. So that makes sense. Y is equal to 2 minus 5. So this is 2 minus 5 is negative 3. Y is equal to 2, plugging in 2. Minus 5 is equal to negative 1. Y is equal to 2. Plug in 3. minus 5, which is equal to positive 1. And then here we can kind of see the trend that there's an increase of 2 each time, right? So negative 3, negative 1, 1, it would be 3, 5, 7, and 9. And we can test if we're actually, maybe we'll just test that last one just to make sure that we've found the right pattern. So I'm going to put 7 in here, minus 5, and that's going to give me 14 minus 5, which is 9, and that's what we determined. Okay, so good. So now I have all these points that I can plot on my graph, right? I have 0 and negative 5. I have 1 and negative 3. I have 2 and negative 1. I have 3 and positive 1. I have 4 and 3. I have 5 and 5. And I have 6 and 7. And I have 7 and 9. Okay? So I have all these points here now that I can graph over on my axis here. Okay? I don't have to label these axes as much just because it's y and x. Just remember that this is your y-axis and this is your x-axis. Okay? And I'm going to go up by positive 1. Each of these squares are going to be positive 1. Okay? Or not positive 1, are going to be equal 1. So this is going to be positive 1, positive 2, positive 3, positive 1, 2, 3, negative 1, negative 2, negative 3, and so on and so forth. Negative 1, negative 2, negative 3. Okay? So, first coordinate, 0, negative 5. So, 0, my x value is 0. I go down to negative 5, and I get my first point down here. Next point is 1, negative 3. I go over to 1. I go down to negative 3. I get my next point here. 2 and negative 1 here. 3 and positive 1 here. 4 and positive 3 here. 5 and 5 here. And then my last point that I can graph is over here. Okay? Now again, in this situation, I can connect these dots because the equation is just what it is here. With the equation, you assume that it's continuous relationship here. So I'm going to drop my first line here and draw it through. All right, awesome. That worked pretty well. Oh, it changed colors on me. Okay, sure. Okay, so there's my graph right there. Awesome, good stuff. So here, use the graph to estimate the value of x is equal to 8. Okay. My Cartesian plane here goes to 4, 5, 6. Not a very good graph to estimate when x is equal to 8, to be honest. So we're just going to use the equation for this, and we'll estimate the next one. So here, when x is equal to 8, you plug in your equation, you plug in what x is equal to in the place of x, so 8 minus 5, and that is 16 minus 5 is 11. Okay? For the other one, use the graph to estimate the value when y is equal to negative 4. Okay, so when y is equal to negative 4, so negative 1, 2, 3, negative 1, 2, 3, 4, I go over to the line, and that looks like, so it's this point here, that looks like that would be 0.5. Okay? It looks like about 0.5. And we can test this, right, by plugging this into our y value. So again, my equation is y is equal to 2x minus 5. I plug in negative 4 in the place of y is equal to 2x minus 5. And I do some algebra, plus 5 on both sides. That's 1. That cancels that out. 1 is equal to 2x. And then divide both sides by 2. And lo and behold, x is equal to 1 over 2, which is equal to 0.5. So we did a good estimation there. Okay? And that was actually, our first one was an extrapolation of the graph. Okay, but the second one was on the line between 2 points, so that's an interpolation, right? Interpolation. All right, just so that we're getting more used to those words. Okay, go ahead and give this one a shot. Okay, same kind of, you have just a different relationship there a little bit. Just like we did the one above, fill in the table first, plot your points, and then answer the follow-up questions. Go ahead and pause the video, and then unpause it when you're ready to play the video. All right, hopefully that went well for you. All right, let's do this together. All right, again, first thing, this is x variables and y variables. All right, so that's going to give me points for the x and y that I can plot on my graph. I have my equation of y is equal to 3x minus 2, and I'm going to start plugging in some of these. And you can see here, I don't have to go all the way to 7. If I plot like 0 to 3 or 0 to 4, that's going to give me enough to get a sufficient line. Okay, so that's all I'm going to do is just those first 5. So y is equal to 3x, plug in 0, minus 2, which gives me negative 2. So negative 2. Next one, y is equal to 3 times 1 minus 2 is equal to positive 1. Y is equal to 3 plus 2 minus 2 is equal to, what is that, 4? Y is equal to 3 times 3 minus 2 is equal to 7. And last one, 3 times 4 minus 2 is equal to 10. Okay, so I have a bunch of points here. I have enough. 1, 4, 7, 10. I can see that I could probably fill in the rest as well if I wanted to, because it's just going up by 3 on this side. Okay, so, but I have enough points to draw my graph. So 0 and negative 2, 1 and 1, 2 and 4, 3 and 7, 4 and 10. All right, awesome. So I have this Cartesian plane here again. On the x-axis, I'm just going to go up by 1s again. 1, 2, 3, 4, negative 1, negative 2, negative 3. You get the idea. On the y-axis, of course this is x-axis, this is y-axis. On the y-axis, I'm going to go up by 2s because I go up by 10 already at 4. If I were to go to 5, I would be at 13, right? So I need to increase my y-axis. So I'm going to go up by 2s. Each of these is going to be 2, 4, 6, 8, 10, 10, 12, and so on and so forth. Okay, those just help me fit my points, all my points there. So let's start. So 0, negative 2 would be here. 0, negative 2. Well, 1 and 1 would be here, right? Because it's 1 on the x, but halfway up on the y would be the 1. Okay, 2 and 4, we got that one. 3 and 7 would be between the 8, the 6 and the 8, and then 4 and 10. Okay, so we have enough points here to draw our line out. So let's say this would be 13. Let's say start from here. Whoa, this is why I don't like this software for drawing lines. It doesn't always do a very good job. Let me try again. So it always swings me down. Okay, then I'm going to draw a nice long line through both points, through all the points and in the direction. All right, so now we're going to use the graph to estimate the values of x is equal to 3. Okay, well, x is equal to 3. I don't really have to estimate that. It's on my table. So when x is equal to 3, I know that it's equal to 7, right? It's right here. It's right there, so I don't really have to estimate it. But I probably will have to estimate when y is equal to negative 4. Okay, so when y is equal to negative 4, I go down 1, 2, 3, 4, right? Okay, and I'm going to go over here, and that looks like it's about negative 2/3. Negative 2/3. Okay, that would be a good estimation there. And then you can check, obviously, both of these with the equation. Y is equal to 3x minus 2. Y is equal to 3 times 3 minus 2, which is equal to 7. So we're right on that. And then y is equal to 3x minus 2. Negative 4 is equal to 3x minus 2. I'm going to add 2 to both sides to cancel out that, which gives me 2. Negative 2 is equal to 3x. And then divide both sides by 3, and lo and behold, I get negative 2 over 3. Okay, so we did a good job in our graph there. Okay, now every so often you're going to get these strange equations that don't look like the typical mx plus b equations that we've been dealing with here, right? This is y is equal to mx plus b, right, where m is equal to 3 and b is equal to negative 2, right? You can identify the m and the b clearly here, right? But sometimes you'll get equations like this where y is equal to 5. So let's test this equation, okay? I have x values and y values. So if x is equal to 0, 1, 2, 3, what is y equal according to this equation? Well, this equation tells me that y is always equal to 5. So y is 5, 5, 5, 5. It doesn't matter what x is, because x isn't even in the equation. It's not even accounted for. Whatever x is, y is equal to 5. So how do you graph that? Well, we have these points, 0, 5, 1, 5, 2, 5, 3, 5, okay, that we can graph. So 0, 1, 2, 3, 4, 5 would be here, 1, 1, 2, 3, 4, 5 here, 2, 5, 3, 5, 4, 5, 5, 5, whatever, 1,000. If x is 1,000, y is still 5, right? And so we get this horizontal line. When you have a y equals equation, you get a horizontal line. Zoom out. Let's try that again. Okay, it looks like that. All right, so that's our y is equal to 5, even though my line's a little bit lower. Okay, so that's how you would, kind of draw a y is equal to 5 line. Okay, it doesn't matter what the x values are, your y is always equal to 5. So I want you to give it a try. Now here, this is x is equal to 6. So I want you to come up with a table of values for both the x and y variables and come up with at least 3 points that you can graph based on your table of values, and then graph them. Okay? So go ahead and pause the video and give that a try. All right, hopefully that went well for you. In this situation, x is always equal to 6. X cannot be 0, 1, 2, 3, 4. It's always equal to 6. Okay? But y can change. Y is not even in this equation. So y can be whatever you want. Y can be 1. Y can be 0. Y can be 3. Y can be 4. Doesn't matter. Okay? We should probably put them in order though. So I'm just going to flip 0, 1. All right. So here I have points that I can graph, right? 6 and 0, 6 and 1, 6 and 3. That'll be enough. And then I just graph these. So 1, 2, 3, 4, 5, 6, and y is equal to 0. So I'm going to have 1 point right there. 6 and 1 will be here. 6 and 3 would be here. I could imagine points all the way up and down. And then you see here when you have an equation that is x is equal to something, then you get a vertical line instead of a horizontal line. Okay? So again, I'm going to zoom out here so that when I draw my line, it's not going to send me over to the next page. And I get something close enough. Okay, I get something like that, a vertical line downwards. All right, so these kinds of equations, they always trick students. Really just kind of use your table of values. Y is equal to 5. No matter what x is, y is equal to 5. Same thing with this one, but opposite. Here, no matter what y is, x is always equal to 6. Okay, and so that would give you a vertical line. All right, so hopefully by the end of these notes, you are able to graph linear equations using a table and then going to the graph, and then that you can also solve problems by graphing linear relations and analyzing the graph, which we did along the way. Your homework assignment is here. It'll be due this coming Monday on Teams. I hope this video was helpful for you. Goodbye.